How can we organize I will talk about the nucleus, okay, the nuclei. But here, let me explain the difference between the classification of atoms and the classification of nucleus. In the case of atoms, to classify the atoms, it's not very complicated because you don't have a lot of atoms. You have just 118. Here, it's easy to classify all the atoms in one table. And the classification will be organized by the number of electrons. As you see, the hydrogen has 1 electron, lithium you have, okay, and so on. So here we follow this method of classification of atom. But in the case of nucleus, of the organization of nuclei, we cannot follow the same procedure because it's more complicated. Why? Because you have many thousands of nuclei. We cannot put them in one table. We must have another method of classification to classify all these nuclei. Typically, the classifications of nuclei are done by the number of neutron and the number of proton. Okay? And these nuclei are arranged in a nuclear chart or nuclear landscape. Simply, it's XY. You have a presentation. Let me show here. You have X and Y. On the Y-axis, you have the number of neutrons. On the X-axis, you have the number of protons. And we present all the elements, all the nucleus, all the nuclei on this chart. Each point here represent one element, okay? This element, it can be stable or non-stable. When I say stable, it means it's non-radioactive element. We don't have decay with the time. When I say unstable, it means it's a radioactive element, okay? You will get some spontaneous decay with the time. It's not stable on the energy level, okay? Here, I show you the number of neutrons on the y-axis and the number of protons on the x-axis. In the next one, just a manner of presentation, I present the number of protons on the y-axis and the number of neutrons on the x-axis. As I said, okay, here we have many regions. You have the stable zone and you have the unstable zone. As you see here, you have the black line. This black line, in this region, you have all the stable elements, all the non-radioactive elements, okay? If you go up, if you go away from this line, up or down, you go to the region of the unstable element, okay? For example, in this region, you have less number of neutron and more number of proton. As you see here, the level of proton and the neutron. And in this region here, you have more number of proton or neutron and less number of proton. Okay, I will talk in details. We go more deeper to explain all these regions later when we talk about the radioactivity. We talk about the alpha decay, beta decay, gamma decay, when we have, in which region we have more alpha decay than beta decay. What are the conditions to have beta decays? Anyway, just here I talk in general. You have one point. If we go at this point, if we go to a level where we have a lot of neutrons, a lot of protons, in this case, we don't have any stable element. Look here. In this region, we don't have black points. We don't have any stable element. Why? Because for the nucleus, if you have a lot of nucleons inside the nucleus, you will arrive to a point where the nucleus becomes very heavy. In this case, it's easy to split the nucleus. So it's easy to have some decay, some radioactive process, gamma, beta, any spontaneous decay. So all these points we talk in details later. Also, we have the magic number. You have here the magic number. The magic number, you have some points here where the elements are more stable, okay, than the other points. Also, in the chapter of shell model, we talk in details about the magic number. And also we talk about the classifications of nuclei on the shell, on the energy states, okay? I think that's all now about the nuclear chart.